Hello, and welcome to my advanced graphics video. The features we'll be covering are normal mapping, parallax occlusion mapping, PO self-shadowing, deferred shading, post-processing, and some additional features. First up is normal mapping. Here I'm moving a light around on a cube that doesn't have normal map enabled. You can see it's very flat. Once I enable the normal mapping, the shadows appear on the bricks. This is done with the normal map texture, and it makes the lighting look a lot better. As I move the light around, you can see the shadows adjusting because of the direction to the light. This also works if you rotate the cube itself. Next is parallax occlusion mapping. This uses a depth texture and a height scale to create a kind of three-dimensional look by offsetting the texture. Here I'm adjusting the scale to make it deeper, and if I enable discarding edges, you can see that it makes the actual edges of the texture look like bricks. Now we have self-shadowing, which casts shadows on itself using the depth texture, and if I enable normal mapping too, you can see that it gives a very realistic look. If you invert the depth texture, you get a very strange effect with the insides of the bricks becoming high. It's kind of cool, but looks better normally. Here I'm demonstrating the roughness texture. This is another mapping technique. This texture can also be inverted to make a specular map instead of a roughness map, and it just kind of inverts the way the lighting works. So I have a material and object system in place for my application, and they kind of interact in weird ways. The materials are shared across objects, and some settings are object specific. So if I make an object, this is a cube, there's no light at the moment, so it just appears black. If we create point light, there you go, and it's purple and black because we don't have a material set on it yet. So if we open the material window, we can set it to a concrete wall and make another cube with the same texture. Here I'm cycling through the various view modes. This just shows the texture on the object itself. It can be useful for seeing what the texture looks like when it's actually on a 3D model. This is also object specific, so when you click it, it only shows it on the one model. If I disable all of the object specific settings, you can see that they reacted the lighting differently. This one is flat shaded and the other one has the PO and normal mapping, so it has a lot higher quality of lighting. If I re-enable them, so now they're the same, but change the material settings, you can see it applies to both objects at the same time. Here is a selection of cubes with various different materials on. Here we have a short video showing deferred shading. Deferred shading looks almost identical to forward shading, except for the self-shadowing, because self-shadowing is difficult, if not impossible, to do with the pipeline that deferred shading uses. Here is some simple post-processing effects. We'll start with grayscale. This is adjusted grayscale, so green is weighted slightly heavier to correspond with how our eyes work. We also have a sepia tone and an inverted post-processing, which just flips the colours. All of these post-processing effects use the compute shader to calculate the change. Here we have our first complex one, which is Gaussian Blur. This has a two-pass system, vertical and horizontal, and you can see that it blurs the entire image. Using that, we can expand it to depth of field, which has a length and width as well as some other variables, which allows you to focus a specific point in the frame to be in focus, and everything else will be blurred. You can adjust the width, which will change the amount that is in focus, and the length is the position that is in focus, as well as the blur intensity itself. If we zoom in, you can see as I move the length, the position that is in focus changes. Here we have Sobel edge detection. This uses the colour to detect edges in the scene. You can also blend it so you can remove the colour and just see the edge detection. Here we have a slightly more detailed edge detection outlining algorithm. This uses the depth and normals and colour. However, normals only work when you've got deferred shading on, because that's what generates the normal texture. The UI I have is dockable, and it supports multiple viewports, so you can have multiple cameras in a scene and dock them wherever you like, and you can control each one individually and see multiple cameras at the same time. There's also 3 different camera types. We have FreeCam, arcball, and orbital cameras. So let's make an orbital camera. This is controlled with the keyboard, the arcball is with the mouse, and the FreeCam is your classic debug camera. And they all work simultaneously, and you can see the cameras moving around on the other cameras. The camera system is made up of rigs and cameras. By creating a new camera, we can demonstrate this. So we'll make this one have a low FOV, so it's very distinct which camera is which. So it creates a new window, which we can dock, and we can assign it to our one rig at the moment. We only have the one rig, so the left-hand camera has no rig assigned, so it can't move, and the right-hand camera has the classic arcball rig, and so you can see it moving now. If we wanted to be able to move both cameras at the same time without having to fiddle around switching rigs, create a second rig. We'll make it an orbital type and assign it to the new one and set the other one back to default, and you can see that they can now both move different ways. I'm actually using the keyboard for the orbital rig, and yeah. The viewport object is a plane that is textured with the view of a camera, so this is kind of an extension of that render to texture. So on the left we have a camera that's pointing straight up, and on the right we can see the plane that is rendered with that camera's view. If I disable it, it stops the update, and so it kind of just becomes a painting, but if I re-enable it, it goes back to acting like a mirror. I can also render to full screen, just to demonstrate that it's possible, and gives you a really clear view of the camera. The UI is pretty dynamic. You can hide any of the windows that are visible, so you can just see whichever cameras you have active and the menu bar, and you can re-enable just specific ones depending on what you're trying to do. Here we have a new scene being loaded. I have several scenes, and if I load this test scene 4, we can see a cube with 8 spotlights around it. This particular scene works better with different skybox, so we'll change the skybox to a space one. If we now load a different scene, we can see all the types of lighting. There are 2 of each types of light, spotlight, directional light, and point light. They're all different colours to make it clear, and they're each facing a different face of the cube. If we focus on this magenta light, we can adjust the cutoff values, and you can see that it changes the way it fades. If we switch over to a point light, as we move it away, it begins to fade and be darker. This is the attenuation in play. Spotlights also have attenuation, and we can adjust the attenuation values to change how quickly it fades to darkness. Now we can play around with the directional light. This is pretty simple, we just change the direction. It affects which way and which phases the light affects the cubes.